and welcome back to my channel. Today in this video we are going to discuss the last few questions from exercise 1B from Selina Concise Mathematics class 9th ICSE. We have already discussed the first 5 questions along with the topic related to 1B. So let's start with question number 6. Here is the question number 6. Prove that each of the following numbers is irrational number. So the first one is root 3 plus root 2. So the hint is we prove a number is an irrational by using one property that all the real number is going to be either rational or irrational. So if we can prove a number is rational and we know that rational and irrationals are not same. So if we somehow prove that a number is not rational, it means it has to be irrational number. So this first type, when we have the irrational number, we can see it is an irrational number because we have the sum of two irrational numbers. But if we need to prove it, we will prove by showing that if we take this as a rational number, then we will get one side as rational and another side as irrational. Means rational will be equals to irrational. That is the contradiction. So here let's take this root 3 plus root 2 as x, and since we have the two irrational numbers as a sum, so we will square it, and if we square we are going to use a plus b whole square identity. So first one is root 3 a square, that is root 3 square is 2, b square is 2, and then 2 times a into b, and this is 2 into root 3 into root 2, which is of course 2 root 6. Now this, and the right hand side is x square, so we got 3 plus 2 as 5, and so it becomes 5 plus 2 root 6 equals x square. Now we will make one side as the irrational number, and we know that the number which makes it irrational is going to be root 6. So we have transferred 5 to the other side, become minus 5, and 2 to the other side become upon 2, and root 6 is an irrational number. Now irrational root 6 equals this. So now we will give the solution in this way, like if x is a rational number, then x square is also a rational number. We know if we have a number in the form p by q or a by b, we take the square, that is also going to be in the form of a by b. So it's a rational number, and hence x square minus 5, if we subtract a rational number from a rational number, it is also going to be rational number. Similarly, if we divide by non-zero number, it is going to be rational. So from here, from this first equation, we can see root 6, which is irrational, and right hand side is a rational number. So from here we got root 6 is also a rational number, which is not true, which is wrong, because a number which is coming in the square root or cube root, if we cannot find the exact value of it, it is going to be irrational. So it means it says that root 6 is also a rational number, which is not true. Hence we have taken this x as a rational number. It is not true. X cannot be a rational number, and since it cannot be rational number, so it has to be irrational number. That's why root 3 plus root 2 is an irrational number. Now let's discuss the second part. Second part, we have 3 minus root 2. Here we can see one number is a rational number, another number which is root 2, which makes this whole number as a irrational number. So what we'll do again with the same explanation. 3 minus root 2, if we take it as x, we can write 3. See, I'm going to take this here and this will here, so it becomes 3 minus x equals root 2. So now if x is a rational number, again we will give the same same explanation. If x is a rational number, minus x is also a rational number, and if minus x is a rational number, you are adding 3 minus x is also a rational number. Now from here, from 1, we can see if this is rational number, it means, and this is same as root 2, so root 2 is also a rational number, which is not true, because we know root 2 is an irrational number. So it means x cannot be a rational number, because we have started with this. So x cannot be a rational number, and if x cannot be a rational number, it means it has to be irrational, and hence 3 minus root 2, which is x, is an irrational number. So similarly, we can do for the third one. We can take this as x, and then root 5 would be, root 5 is going to be x plus 2, and with the same explanation we can see it is a rational number, and it means this is also a rational number, which is not true, so we get contradiction, and hence root 5 minus 2 would be irrational number. Now from 7th to 11 questions, we can see, right, we need to give a pair of irrational numbers whose sum is either rational, irrational or rational, and whose difference is going to be irrational, whose difference is going to be irrational. So the theory, the concept behind it, we know that a number, like for example it is 1 plus root 2, root 2 is a number which makes it irrational, because if it would be like something 3, then it is going to be 4, which is going to be rational. So root 2 in this and in this also, root 2 is the number which makes it irrational. So if we require an irrational number, then what we can do, we will, and the sum to be irrational number, we need to keep these two number somehow. So if we take the 1 plus root 2 and 2 plus root 2, and we are adding them, 1 plus 2 will be 3, and root 2 plus root 2 will be 2 times root 2, and again still it is still there, so that's why it is going to be irrational number. So the sum of the two irrational number is irrational in this case. For the 8th one, write a pair of irrational numbers whose sum is rational. So now again, if we want to get the sum to be rational, we need to get rid of this number which makes it irrational. So root 2 and minus root 2, if we add them, we know that they are going to be an opposite in sign. So a minus a is always 0. So if we add them, root 2 minus root 2 would be cancelled, and we will get only 1 plus 2, which is 3, and which is rational. So that's how we decide. Like similarly for the third one, 9th one, write a pair of irrational numbers whose difference is irrational. So now we require the irrational number, and difference means subtraction. We could have chosen any other number which will not, of course the irrational part should not be cancelled. Otherwise I have chosen this same type of irrational numbers. Now the difference, so if we are subtracting, there is a minus, and if we subtract it, it will make it positive. So here we will get 1 and minus 2, and root 2 and plus root 2, that is going to be 2 root 2, and if it remains there, it means it is going to be irrational number. So finally we got minus 1 plus 2 root 2, which is irrational number. So in the 10th part, we can see, write a pair of irrational number whose difference is rational. Whose difference is rational means you are going to subtract it, and if you have same numbers, same term which makes it irrational, and if you are taking difference, means after multiplying by minus it will become minus, so that will cancel these two, and we will get rid of this root 2, means it is going to be only rational parts. So you can subtract 1 minus 2, which is going to be minus 1, and which is of course rational. For the 11th one, write a pair of irrational numbers whose product is irrational. So if we require again the irrational number, so we can choose any pair, and if you multiply, the only thing is when the product is going to be rational is when we use the identity a plus b, a minus b, then it is going to be a square minus b square. In that case only we get the rational number. Otherwise we multiply any two pairs of the different pairs, we will get irrational number. So 1 plus root 2, 2 plus root 2, 1 into 2, 2, 1 into root 2, root 2, and 2 into 2 root 2, 2 root 2, and last root 2 into root 2 is this. So we got 1 2 from here, and root 2, 2 times root 2, 1 times root 2 is 3 times root 2 plus 2, and we add the like terms, we get 4 plus 3 root 2, and since root 2 is there, it is going to be again irrational number. I hope it is clear. Now the last one, as I have discussed, write a pair of irrational number whose product is rational. So in this type of question, we only need to get the same terms with the different sign. So here it is 1 plus root 2, here it is 1 minus root 2. If we multiply them, we will get the identity a plus b, a minus b as a square minus b square. It's not required to remember the identity. You can simply multiply 1 into 1, 1 into minus root 2, and then root 2 into 1, and then minus into root 2. Root 2 is 2, so this would be cancelled, and finally you'll get this identity, and that is going to be 1 square minus root 2 square. 1 square is 1, root 2 square is 2, and minus still there, and now you got minus 1, which is rational number. So that is how you choose the pair of irrational number. There are infinitely many pairs of irrational number whose sum, product, difference, everything you can find accordingly. And here's the 13th question. Write in ascending order. So we have seen, in order to check whether two irrational numbers are in order, root x and root y, we can only say when we can compare the numbers. So for example, if x is greater than y, then only root x is going to be greater than root y. It can be any root, third root or fourth root, or for any root for that matter, but that should be same. So here it is 3 root 5 and 4 root 3. So if 3 is outside, it means, we can understand that it has to be inside the root in a pair, then we can take it out. So we can do the reverse process. 3 is outside, so in order to bring it inside, you have to multiply by 3. Same 3 into 3 we can do, and then we get 45. Similarly for this, 4 into 4 into 3, and the concept behind it is the same. Like if we have a cube root and you have 2 in a pair of 3, then we can take it out as 1 single 2. So the same for the square root, it was out, so we bring it inside by multiplying, taking the square of it, and then we got 48. Now we can see 45 is less than 48, and hence square root of 45 is going to be less than 48, and hence we got root 45 is we got root 45 from 3 root 5, so 3 root 5 is less than 4 root 3. That's how we will decide. Similarly for 2 cube root of 5 and 3 cube root of 2, in this case this is 3, so you will bring this 2 inside by taking the cube, and we get 40, and from here 3 cube root of 3 into 2, we got 54. And now since 40 is less than 54, it means the cube root of 40 is less than cube root of 54, and hence 2 cube root of 5 is less than 3 cube root of 2. The third part is when we have three irrational numbers. So we are going to take it inside by just the same method, outside square root. So it would be square of the 6 into 5, and we can get 180, 147, 132, and then from these numbers we can compare. Once we can compare from the number, we can directly write this final value. So let's have the question number 14. Write in ascending order. Now again the same, we need to in the descending order. In descending order means first the bigger one and then the smaller one. So we will do in the same way. The process is same. There is a fourth root, so inside this would be 2 to the power 4, and then we can see 96 is less than 162, or we can say 162 is more than 96. So fourth root of 162 would also be more than fourth root of 96, and hence we get this number. Similarly for this also, 7 will go inside with 7 square, 3 will go inside the root with 3 square, and then we can compare from these two numbers and we can find out which one is bigger. Now this is something different because there are different roots. It is 6th root of 15, it is 4th root of 12. Now we need to compare. In this case, as we have discussed in the previous part, that if you have m here and here it is 2, and you want to make it mn, so you can multiply n here also and you can make the power n. For example, if you want to make this 3 sixth root here, so you have to multiply by 2, so same power you have to take here. So we are going to first of all find the LCM so that we can take the common nth root. For example, 6 and 4, the LCM is 12. So I will make this 6th root as 12 by just multiplying by 2 here and taking 2 here as well. So we got 225 with the 12th root. Similarly for 12, in order to make this 12, we need to multiply by 3. So we will take power also as 3. So we got 12th root of 1728. So now we can compare that 225 is less than 1728. So its 12th root would also be the same inequality, and hence we get this, and we can compare. For here now, if there is no root given, it means it is square root, so LCM, and then we make this as a power and we can compare. And here's the next question. Insert two irrational number between 5 and 6. So there are so many ways. I'm telling you all the ways, but let's start with this. Whenever we have integers and we require one or two irrational number between them, the best way is to multiply the number and take the square root. That would be the number between the two. That would be an irrational number between the two integers. So here root 30 is in between 5 and 6. So since we require one more, so you can take next two numbers as this. So I multiplied the 5 and root 30, and then I have taken the square root. Now 5 is going to be less than this number, and this is going to be less than 30, and this is going to be less than 60. So there are so many other ways we can directly use the property of irrational number, that we know the decimal expansion of irrational number, non-terminating, non-repeating. So we can take it also as 5.10, 100, 1,000, and there is no repetition, so it is going to be irrational number. Another number again we can take it as 5,1, 511, 5,111, 5 4 times 1, and then so on. Again, there is no repetition, so it's not recurring, it's not terminating, so it is going to be irrational number. So any which way you can give your answer. So 17th one, insert 5 irrational numbers between 2 root 5 and 3 root 3. So in this type of question, they generally ask because they know that there is a gap of 5 or 6. So here first of all we will bring the total number in a square root. So again the same method, 2 is outside, so inside it would be 2 square into 5, root 20, and root 27. Now between 20 and 27 there are integers 21, 22, 23, 24, 25, and 26. Since 25 is the only number which is going to be a square number, so its square would be square root would be rational. Otherwise we can take any number, 20, this square root, this square root, and this square root. So 21, square root of 21, 22, 23, 24, 26 would be in a same order also, and that is going to be in between root 20 and root 27, which is 2 root 5 and 3 root 3. So these are the numbers. So in case they require little bit more, so you can do any other method, so by the previous method also. So next let's discuss the 18th question. Write down two irrational number between root 2 and root 3. So this is another method to find the two irrational numbers. Again, if you know that root 2 is 1.414 and so on till 3 decimal place, and root 3 is 1.732 and so on, then you can always use the method of non-terminating, non-recurring decimal, this decimal expansion of the irrational number. Otherwise, let's have this method. Root 2, if we take the square of it, we will get 2. And we can write 2 as 2.00. Similarly for root 3, 3.00. Now two square numbers we require between 2.00 and 3.00, and actually we require the two square number between 200 and 300. So we know this first square number we can take 225 15 square, and then 256 16 square, and then that is it. So we can see from here that this is going to be square number, and we require the rational numbers. So if we take the square root of it, we'll get 15 and 16. And if we take decimal in between two decimal place, after two decimal place, then we will get this as 1.5, and this is 1.6, which is of course rational number. So now we have two square numbers between 2 and this 3 as 2.25, 2.56, and hence again this 2 is, we know already, the squares, and hence the two rational number between root 2 and root 3 can be 1.5, 1.6. Otherwise, I told you in the case of irrational number, if you want to find rational number, there is a 1.4, 1.7, there is a gap, we can get 1.5, 1.6 directly, and we can write your answers. So there are infinitely many rational numbers, but we focus on few. Now the 19th question, write three rational numbers between root 3 and root 5. Again, by that method we will find, we know the square of root 3 is 3, which is 3.00. Similarly for 5. Now we require the three square numbers. If we know the square numbers between 300 and 500, then you can directly do it, because 324, which is going to be 18 square, 361, which is going to be 19 square, and then 400, it is going to be 20 square, so 2.0 square. So now once we have this, and be careful, we need to be very careful when we apply the decimal. We should always have the decimal after even number of decimal places, because otherwise we cannot find the root like that. The square would not be in that way. So here we got root 3.24 as 1.8, root 3.61 as 1.9, and similarly for this we got 2. So three rational numbers between root 3 and root 5 are 1.8, 1.9 and 2. Now let's do the simplification form, simplification 1. So the question number 20, simplify each of the following. We know that in the addition part we cannot add the two unlike terms, but we can multiply the unlike terms. So here root 16 and so fifth root of 16, fifth root of 2. So you can multiply, it is going to be fifth root of 16 into 2, and 16 into 2 is 32, and 32 from the prime factorization we can see, or I would suggest, if you can remember, if everyone everyone should remember the two powers to till 10 to, so it is going to be 2 to the power 5. So 2, 16, 2, and then 8, 2, and then 4, and then 2, and 2, and 2, and 1. So we got 2 to the power 5, 32 as 2 to the power 5. And if we got same and same here, so it is simply, we can cancel, and it is 2. Or we can say there is a pair of 5 2's in the fifth root, so it will come alone outside. Similarly here it is the common fourth root, and 81, again 81 is 3 to the power 4. If we don't remember, we can always do the prime factorization in this way, and we can get what will come out. In the third part, if we are going to multiply the two irrational numbers, we are going to simply multiply 3 into this whole bracket, that is 3 into 4, 3 into root 7. Similarly for root 2, plus root 2 into the whole bracket, plus root 2 into 4, 4 root 2 plus root 2 into plus root 7, that is like terms now to the same root, so we can directly multiply 2 into 7, the square root. So it becomes 12, it becomes 3 root 7, it is 4 root 2, and this is 14. Now we cannot get any like terms, it is root 7, root 2, and root 14, so we cannot add them, so that's the final answer. For the fourth part, root 3 minus root 2 whole square, it is of the type a minus b whole square. I am going to use the identity a square plus b square minus 2 times ab. So root 3 square and square root would be cancelled, we get 3, this similarly this, and now they are same root, so we can multiply. Root 3 into root 2 is root 6, so we got 3 plus 2 5 minus 2 root 6, and that's the last question from exercise 1b. I hope it was of some help. So let's meet again in the next video. Till then, thank you so much.